Dr. Agarwal. Today I'd like to present to you about what I've been working on this past summer. So the goal of our project in the pre-trial analysis was to recognize how fast someone is speaking based off the rate of their breathing. So we gathered speech data as part of the breathing analytics project, and we aim to conduct multiple experiments with different parameters such as the words per minute, posture, brightness, and text length, so that we can get a varied amount of information to see what data would suit us best. We then analyze this data to correlate breath patterns with each other. So to start, we placed a spire tag on the left waistband of the subject, and while collecting data, we tried not to induce speech or any interrupted speech, laughing, coughing, sneezing that might alter the data that we wouldn't like. So starting off, in experiment 1, the subject took a deep breath before saying all the words. They tested 60, 120, and 180 BPM while reading off a teleprompter that said it at that exact speed. We used the long text that was generated by ChatGPT in order to be able to, that was just general conversational text that we asked it to generate, and all the words were pronounceable, but being the text was long, we got a lot of data that we weren't sure how to comprehend. Moving on, we were suggested by Mr. Matsu, to shift our collection from 40, 80, or 120 BPM, because we noticed that 180 BPM was a little bit too fast for Rich and our subject. So we decided to say the phrase one fish, two fish, red fish, blue fish, which was a lot more simple and comprehensible. As you can see, Rishan took a big deep breath here, and then said one fish, with the crest being the beginning of the word and the troph being the end of the word. So we can clearly see each word being said, right here, 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 and so on. For experiment 4 to 5, after meeting at the bi-weekly presentation, you had some suggestions for us that maybe we should change it to long text and stop using a metronome to get more accurate results, because experiment 2 to 3 might not have, 1 to 3 might not have been fully representative of what normal speech text would be like. So after switching to experiment 4 to 5, in which we stopped using the metronome and spoke at a comfortable pace, we again got the same results pretty much as experiment 1, in which the data was largely incomprehensible because of how much there was. In experiment 6, however, we changed it to natural conversation between Rishan, the test subject, and me. I'm not collecting data, but Rishan has a spire tag on him to collect the data. And throughout, the subject thought and responded to every single question that I asked him while engaging in the conversation. So that might have been one of the most accurate ways to get data. And in experiment 7 to 8, what we did was, I as a subject practiced balanced breathing, in which I went in, out the other nostril, in, and then out the other nostril. So throughout, I had 10 minutes of regular breathing, and then in the middle, I actually had, we implemented the balanced breathing, followed by another 10-minute interval of regular breathing. So in our data, we noticed really sharp trophs in intervals at the starting point, end point, and sharp breaths like this. This is when Rishan really took a quick breath, as seen in the video. And another thing we noticed is that when reading the long text at 40 BPM, you can see that the force data gradually goes down over time. But compared to 80 or 120 BPM, the data is more straightforward. So we still don't know why this is, but that's just an observation we made. So another big challenge to us was the irregular data that we collected. At some points, this could be caused by the spire tag being shaken around. There would be points at which it would dip and come back in less than a tenth of a second. So obviously this is not indicative of actual human breaths. So it's highly unlikely that this is. So we really know that this area does need to be cleaned. And one of the clever ways we decide to clean it, at least first identify it, is by graphing the derivative of the function. So with this command, we can find spikes in the derivative that stand out from the rest of the data with irregular jumps. So as we can see at x equals to 900 or 1300 to 2000, we saw a lot of this data jumping up, and this is largely that we think is because of not because of human breathing, but because of the spire tag. So this is the positions that need to be cleaned with the script. So some of the challenges we faced was that the spire tag's reading of the force data would randomly spike, as you saw previously, and it resulted in data cleaning to adjust it. We saw that the issues with the spire tag being backward or upside down would also happen, as you saw in a couple slides before, in which the trophs were sharp, but the tops, the crests, were round. That's completely inverted.
Mm-hmm.
So what we did last summer with DISP 1429, I believe, I graphed the data and then saw if that pattern was there, and if it was, we flipped it. Same with the noisy, but noisy, when we indicated it as noisy, that's where the rest of the team can go in and clean that specific data. Using a metronome was also not simulative of natural speech, which we corrected after experiment 3. And the inability to distinguish each word in the breathing segments with long text was largely due to the variance. So this might be, maybe it'll take a lot longer, but we would need more data analysis to figure out what word is being said at that particular time. So some of the key takeaways from this experiment was that we gained a deeper understanding of how to interpret and analyze the breathing patterns in relation to speech rates. We also understood the value of repeated trials and adjustments to refine the experiment and improve the results to make sure that we have a certified conclusion. We also want to say that collaboration and communication was especially important to be able to know what everyone is doing and what might not work or what will work.
Mm-hmm.
And I personally refined my process about the scientific method, watching how the PhD students really collected data, organized it in the next slide. So in the future, we do want to implement more data analysis to predict speech patterns based on breathing rates with a higher accuracy. So this would mean just a larger scale of data, more accurate sensors, And we also want to expand our research to include a diverse range of participants. As of right now, our only participants are between the age of, as far as we know, 12 to 20. So that's just a younger population. We want to see how maybe a different age or health conditions might play an impact. We also want to collect more data with a higher quality sensor to ensure more accurate data. And possibly we could partner with speech therapy institutions to further use their resources to find out what exactly is going on with our data. So in conclusion, our speaking rate was at a steady beat and can be tracked with the exhale of a breath in which the crest indicates the start and the troph indicates the end, as we saw with 40 BPM. We also noted that lower BPM, such as 40 BPM, and we also saw in another experiment 60 BPM, we don't know the exact threshold, but at that specific threshold, it would go down as a breathing rate force data.
Okay.
Thank you for the opportunity.
Okay. Let's go.